What I'd like to do now is just work through another couple of examples. Once again, the trigonometric equations. So we've got to find an unknown, got to find the angle. We're given the domain, so let's just look at the first one. And straight away we see that the x, the angle, lies between 0 and 2 pi. Now that straight away tells us that we're working in radian mode. So whenever you see multiples of pi here, we know that we are in radians, and we've got to give our answer in radians, not in degrees. Okay, so we've got to find this angle such that the tan of the angle is equal to negative 2.1. We probably best off drawing our unit circle and identifying which quadrants with tan is positive and negative in. So we've got all stations to central. So we know we're working with the tan ratio, and the tan has got to be negative. So if the tan is negative, we've got this quadrant here, and we've got this quadrant here where tan is negative. This says tan's positive, and all are positive there. So we know we're going to get angles in this quadrant and this quadrant. So this is tan is negative here. Our angle has got to be between 0 and 2 pi, in other words, one complete revolution. So maybe it's a good idea just to go around. We know that is 0, 180 degrees is pi. This is halfway along. Halfway from 0 to pi is pi on 2. 0 is the same as 2 pi. 2 pi is one complete revolution. So halfway from pi to 2 pi is 3 pi on 2. So we're going up by pi on 2. So we've got 0, pi on 2, pi, then we add another pi on 2, we get 3 pi on 2, and then we add pi on 2 to 3 pi on 2, and we get 2 pi. So we're going up by pi on 2, and don't forget pi on 2 is 90 degrees. So we know that our angle, because the tan is negative, is going to be in this quadrant down here and in this quadrant down here. And just like before, we find the basic angle. We forget about this sign here, and we know that the tan of alpha, alpha is the basic angle, and it'll be the angle that's in the first quadrant. And all we want to do is find the angle, forget about that minus, is just what that is. Tan of alpha is equal to 2.1. So we want to find what angle has a tan of 2.1. You need to change your mode on your calculator, so you're now reading in radians, not degrees. So that's usually done through a mode button on your calculator, and then you can select whether it's in degrees or radians and go into radians. Now just be careful if you go into radian mode that if you do a question later on that requires degrees, you need to switch back. So we put in, once we get into radian mode, on calculator. So you do that there, and we go tan, shift tan, which will bring up tan to the minus 1, 2.1. This once again will give me alpha, which is in the first quadrant. It's not the answer, we're trying to work out x, but this just gives us the angle in the first quadrant. And if you put that in, you'll get 1.1264. So that is equal to alpha. That is the angle in the first quadrant. So we put in tan to the minus 1 of, or inverse tan, which is arctan, 2.1, enter, and that is the angle in the first quadrant. Now don't forget, 1 radian is about 60 degrees, so this is just a little bit more than 60 degrees. That gives us alpha. Now, to work out the angles that will solve this, x, we know that x has got to be either in this quadrant, and that will be my alpha. So we go all the way around to pi. Maybe another colour to show that. We go all the way around to pi, and then we come back to their alpha. So if we go green all the way around to there, we get pi, and then we take off alpha, we will get back to that angle, which will be one of my solutions. Or, let's do it in another colour, it's going to be the angle down here. Now the angle down here is alpha off away from the horizontal axis, so you'll go all the way down to there and come back alpha. So if you go all the way around, x is equal to 2 pi minus alpha. 2 pi minus alpha is going all the way around and then coming back alpha. That's why we find the basic angle. And using your calculator, you can just put pi minus alpha where this is alpha, and you'll get 2.0152, and 2 pi minus alpha will be equal to 5.1568. Now once again, we can do a check on this. If you put tan of that and you're still in radian mode on your calculator, you should get negative 2.1. And if you put tan of that angle on your calculator in radian mode, you should get negative 2.1. So you should be able to check your answers there. Another thing to look at is that, as we said, 1 radian is around about 60 degrees. So 2 radians is going to be around about 120, which is certainly in the second quadrant. 5 radians, a bit around about the 300 degree mark, and this is from 270 to 360 if we're talking degrees. So there are my 2 answers. Either one of those 2 answers is between 0 and 2 pi. 2 pi is 3.14, so that's about 6 point something, so these 2 lie in the domain. Okay, let's look at the second example, done a very similar way, but we haven't got to this stage yet. So we need to rearrange this equation up here in B. We look over here and we see once again we're in radian mode. So we keep our calculator in radian mode. So we want to get tan by itself. Now to do that, we take the minus 6 to the other side and we get 2 tan squared theta equals 6. And we divide both sides by 2 and we get tan squared theta is equal to 6 over 2, which is 3. And then we find the square root of both sides. When we find the square root of tan squared, we just get tan. And we find the square root of 3, we actually get 2 answers, plus or minus square root of 3. If you square the square root of 3, you'll get 3. If you square positive the square root of 3, you'll get 3. So we've got 2 answers here and 2 possibilities. So tan can be positive or negative root 3. We know also that theta is going to lie between 0 and 2 pi. So once again, we draw our unit circle and we've got C, A, S, T. So we know here that tan is positive here and here. So there tan is positive and here tan is negative. So in other words, we are going to get an answer that is in all 4 quadrants because tan can be plus or minus root 3. So we forget about the plus and minus and we say what angle, and this is the basic angle. Oh, let's go back to black here. We're saying what's the basic angle that has a tan of root 3. So alpha is the angle that has a tan of root 3. Now root 3 is root 3 on 1. That is the basic angle. It'll be the one in the first quadrant. Then we can work out the angles in the other quadrant from the basic angles. All right, so we say, oh, root 3 on 1. I remember one of those special triangles. We've got 1 to root 3. And in radians, this is pi on 3 and this is pi on 6, which pi, don't forget, is 180, so that's 60 and that's 30. So what angle has a tan of root 3 on 1? Root 3, there's opposite, there's adjacent, and so opposite over adjacent, so we've got pi on 3. So alpha will be equal to pi on 3. So that will be one of my answers. So that's the basic angle, but it is also one of my theta values because it can be positive root 3. Over here, we get 180 minus pi on 3. So theta equals pi on 3. Let's do the positive ones first. It'll be pi on 3, which is the basic angle in the first quadrant, or 100, or pi plus pi on 3. And that's where the two quadrants where tan is positive, or now the two where it's negative is in this quadrant up here where sine is positive, so that'll be pi minus pi on 3, always working off the horizontal axis, or this one in here is 2 pi minus pi on 3. Now we should simplify these. Pi plus pi on 3 is, now we make that's like over 1, so that's 3 pi on 3 plus 1 pi on 3, which is equal to 4 pi on 3. So pi plus pi on 3 is 4 pi on 3. Pi minus pi on 3 is 3 pi on 3, 3 pi on 3 minus 1 pi on 3 is equal to 2 pi on 3. So that is the getting that together. Pi plus pi on 3, so there's an answer, there's an answer. And now we've got to simplify this. So 2 pi over 1 is 6 pi on 3. Just multiply top and bottom by 3, minus 1 pi on 3 is 5 pi on 3. So there is another answer. So we get our 4 answers. This is in the first quadrant. This is in the third quadrant, which is down here. This is in the second quadrant, and that's in the fourth. So it's normally doing them in ascending order. So let's go across the bottom so I don't have to move. Have we got theta? Yes, is equal to pi on 3. 4 answers. First quadrant. What was the answer in the second quadrant? That was pi minus, which is this one here, which simplified to 2 pi on 3. Third quadrant was pi plus pi on 3. Where did I do that? Up here. Pi plus pi on 3 is 4 pi on 3. And the last one would be 2 pi minus pi on 3, which is 5 pi on 3. Okay, so there we go. If we were to number them, we know that this is 0 and this is pi. Now pi is 3 pi on 3. Halfway around is 1.5 pi on 3. And this is also 6 pi on 3. 6 pi on 3 is 2 pi. And if we're going up, so we go 0, 1.5, 3, and this is 4.5 pi on 3. Just another way of looking at it. Pi on 3 is certainly there. That's 1 pi on 3. 2 pi on 3 is certainly in between those two. 4 pi on 3 is in between those two. And 5 pi on 3 is in between those two. So there we go. There are our solutions.